All right, so we're going to compare function notation. I'm going to do, you have a visual representation here, and here you have a table. Just in case you forgot how to write an equation, I'm going to do the one from a table. So read each statement about the provided 4 different functions. So you've got f of x, g of x, h of x, and k of x. Decide if you agree or disagree about that statement. Explain your thinking, or provide an example for why you agree or disagree. So I'm just going to look at the tables. You can look at the visual representation of the graphs. A table of values are shown for the graphs for h of x and k of x right here. All right, so that means I'm answering all the questions that have h of x and k of x. So here are 2 functions. The values of h of x will always exceed the values of k of x. Do I agree or disagree? So looking at the values of h of x, 0 is bigger than negative 10, 2 is bigger than negative 9, 4 is bigger than negative 6, 6 is bigger than negative 1, 8 is bigger than 6, but it looks like the gap is closing, so I don't think I actually agree with this, but in order to prove it, we're going to go ahead and put it in. Looking at this equation, what type of function is it? What do you see happening each time? How do I go from 0 to 2, 2 to 4, 4 to 6, 6 to 8? Hopefully you can see that you're adding 2 each time. So if I'm adding 2 each time, that's my rate of change. My constant rate of change is adding 2 every time. All right, which makes this a linear function. So in order to write the function for h of x, I'm going to write it right here. H of x is equal to my constant rate of change, which is 2x. And where do I start? At 0. All right, where x is equal to 0. All right, so this is my function for h of x. Looking at k of x, it goes negative 10, negative 9, so that's plus 1, negative 6. So this one looks like it might be quadratic. And you get used to seeing this, and I'm going to show you why. So this is plus 1. Then this is plus 3, then this is from plus 5, then this is plus 7. And you can see that the change between that 1 and 3 is plus 2, this is plus 2, this is plus 2, so it's going to be quadratic. But again, I don't want you to worry so much about quadratic, so what I'm going to do is put it in the table and remind you how to get this equation. So we're going to type it in, so it's 0, 1, 2, 3, 4, and it's negative 10, negative 9, negative 6, negative 1, and 6. All right, so we're going to zoom fit, click this. All right, so you can see it clearly looks like it's quadratic, but sometimes it could be exponential. So just to make sure, we're going to type in our quadratic function. So coming right here to our formula sheet, we're going to go to quadratic equations, and we're always going to use the standard form. So that's going to be ax squared plus bx plus c. We're going to go ahead and type that into decimals. So y equals ax squared plus bx plus c. All right, and you can see there's an error. 2 things that you have to remember that you have to change. All right, for one, the calculator, you're trying to tell the calculator, look at this table, but it's calling the table x1, y1, where you're calling the equation just y and x. So we need to change that to x1 and y1. So everywhere I see a y or an x, I'm going to put a 1. And sometimes this changes to x2, y2, so make sure you change it accordingly. And the other thing that it doesn't like is this equal sign. We're going to delete that, and we're going to put a tilde or a squiggly line. You click ABC, and there it is, or shift right underneath the escape key. All right, so there is our equation. I'm going to go ahead and just type it up so I have it. So y equals, a is equal to what? 1. So this is 1x squared. So that's going to be x squared, which is the same as saying 1x squared. And then c, because b is 0, so there's no bx, and then c is negative 10. So this is my equation, and if that's right, it's going to match perfectly, which it does. All right, so k of x is equal to x squared minus 10. All right, now that I have my 2 equations, I can answer any questions that they have. So I'm just going to delete all of this. I'm going to put my 2 equations here just so that I'm ready to answer it. This first one is just 2x plus 0, so that's just 2x. So here are my 2 equations, which gives me a visual just like you have right here. All right, so now that I have a visual, I can answer whatever questions. The values of h of x. So h of x is the linear one. So the red line always exceeds the blue line. That's not true. So it exceeds the blue line where it's above. That's what exceeds means. Right here, from here to here, it exceeds the blue line because the blue line is underneath it. But after this point right here, right, the blue line exceeds the red line. In other words, the blue line is above the red line. So I disagree with this statement. And when I explain why, I'm going to say, because after roughly 4.3 is it seconds, it does not say. I'll just say after roughly, so let's say that after approximately, I like that word, approximately, 4.317 x values. Now, if it had time, I would use time, but it doesn't have anything to do with time, so it doesn't. So I don't know what the x values are. So after approximately 4.317 x values, then k of x exceeds h of x. So basically, after this one, the blue line, which is the quadratic, which is k of x, is bigger than the red line, which is h of x. All right, another question that has h and k, this one right here. So let's go ahead and answer number 4. The values k of x begin to exceed the values of h of x. So the value of the quadratic k of x exceeds h of x. So the quadratic exceeds the red line within the interval. So within means inside of, okay, 4 to 5. It does, because at 4.3 is when it starts to exceed. So that's within the interval of 4 to 5. So I'm going to agree with this. And my reasoning being is after 4.3, k of x exceeds h of x. Just that simple. All right, so you're going to now go ahead and answer. Here's the visual for this. And they have given you equations, so if you prefer to put the equations in here to compare them, that's fine as well. Go ahead and answer questions 1, 3, and you're also going to, this is a different question, complete the table here, and then do 6 and 7. Let's practice.